Hello and welcome back. Today in our section for section 9.5, we will talk about how to graph a parabola. Now, unfortunately, because the section, for some reason, they actually don't include the focal points, we're not going to talk about that. So we'll probably save that for another video. So in general, what I want to do is, given the equation, I want to sketch out what the parabola looks like. Now, for the parabola, there is a general form that we learned, and that was back in chapter 5. That general form being ax squared plus bx plus c is equal to y. And your parabola will either open upward or downward depending on what a is equal to, the coefficients. So in our case, let's just go ahead and review back with the following question. How to sketch out y is equal to 2x squared plus 8x minus 1. At the very beginning of this, the way we did it was by completing the square, but eventually we found an easier way, and that easier way is to find out what is the vertex of the parabola. If you recall the vertex, the x value of the vertex is supposed to be equal to negative b divided by 2a, where b is supposed to be the coefficient in front of x, whereas a is the coefficient that is in front of x squared. So in our example, then that means that it will be negative 8 divided by 2 multiplied by 2. So that's going to be negative 8 over 4. So the answer is equal to negative 2. Once you find out the x value, we can go ahead and put that value back in order to find the y. So the y value of the vertex is going to be 2 times 2 squared and then plus 8 times 2 minus 1. And that will then give us, negative 2 actually, and negative 2 over here. So the first one looks like it's going to give us 8. Second one's going to give us minus 16, and then we have minus 1. So in total, that is going to be equal to negative 9. So vertex, that is going to be at the coordinate negative 2 comma negative 9. In addition to that, we also find another point, which is the point that is on the y-axis. So the y-intercept, that is simply by letting x is equal to 0 to solve for what y is equal to. And that y-intercept is always going to be this last number c over here. So it's going to be 0 comma negative 1. Finally, we're going to go ahead and look for the symmetric point, the point that is a mirror to the y-intercept. And to help you see that point, let's go ahead and sketch out what the vertex looks like first and then the y-intercept. So we're going to go to negative 2, and then we're going to go down to 9. So 1, 2, 3, 4, and then negative 9 should be somewhere around here. So this is going to be our vertex. The symmetric point, 0 comma negative 1, is located on the y-axis, and that's located over here. Now, if you draw the parabola, you technically can draw it with those 2 points because remember, the vertex is the lowest point. To help you see visually a little bit better, I'm going to go ahead and draw kind of like a dotted vertical line right here. That's going to be our middle. So our symmetric point, that point that we did not solve for, but we can see it's going to be on the opposite side over here. It's going to be a mirror, and your parabola would look something like the following. And thank goodness I said sketch because my graph would actually suck if I were to do this accurately. But there you go. So there is going to be my y-intercept, which is 0 comma negative 1. So this symmetric point, according to this, well, this is a distance of 2 from here to here, and that means that this is a distance of 2 from here to here. So the symmetric point is going to be at the coordinate negative 4 comma negative 1 then. So negative 4 comma negative 1. Some of you guys might have remembered that this value right here is really just double of this value, whereas the y value is the same as the y values over here. All right, so that is just kind of a recap from last time of how to sketch a parabola using, well, what we know and, kind of like the quick way. So now we're going to go ahead and sketch the parabola again, but this time with a different orientation because we're going to flip our variables then. So in this case, it's going to say x is equal to negative 3 times y squared plus 24y plus 2. To help you kind of visualize what's going to happen, we're going to switch x and y. So that tells me that the parabolas are going to either open to the left or either to the right. And in this case, I'm thinking it's going to open to the left because of this negative 3 that's over here. So let's go ahead and test that theory and then go ahead and go at it. So first things first, same as before, we're going to go ahead and solve for the vertex, right? And our vertex of the variable, at first it was the x value of the vertex, but now we're going to solve for the y value of the vertex because, well, we changed from x to y and y to x. So similarly, it's going to be negative 24 divided by 2 multiplied by negative 3. Same procedure, but just solving for y this time. So negative 24 and then divided by negative 6, and that's going to give us 4 then. So I'm going to use that to solve for the x value of the vertex. So x is equal to negative 3 multiplied by 4 squared, and then plus 24 times 4, and then plus 2. Cleaning that up as much as possible, that's going to be 16 minus 3, 16 times negative 3, so that's negative 48. And then we have the plus, that's going to be 96, and then plus 2. Let's see, that is going to be negative, let's see, is it negative? Looks like it's going to be positive. It's going to be 50 right here, right? So yeah, it looks like it's going to be 50 because it's 48 and then plus 2. Okay, so there you go. So that means our vertex is going to be 50, comma 4 then, right? Because remember, it's going to be x comma y, not y comma x. All right, so let's see. Now that we have the vertex, same thing. We're going to go ahead and solve for not the y-intercept, but rather the x-intercept then. So the x-intercept, we're going to go ahead and set y is equal to 0. And if I solve for x, it's just going to be this last number once again, which will go in here, and that's going to be a 2. So put those two things together. The vertex is located at 50, comma 4. So that's going to be somewhere over here. I know my scale is a little off, but hopefully that's okay with you. So 50, comma 4. Then we have the x-intercept, which is 2, 0. So that's going to be somewhere over here. So it's going to be 2, comma 0. Again, we're going to go ahead and draw a line, this time a horizontal line to reflect where the middle is going to be. And from there, hopefully you can then see the symmetric point on the opposite side like a mirror, and that's going to be our symmetric point then. Put it all together, your parabola is going to look something like this over here, right? And if we want to find out the symmetric point, again, look at how much you're traveling up and down then. This is going to be a total of 4 because you're going from 0 to 4 over here. Then that means you're going to go up by 4 as well. So that means if we put it all together, the symmetric point is going to be 2, just like before, comma 8, and just like before, notice that it's basically double these two values, and this value and this value is exactly the same thing. So there you go. It's not too bad. It's just basically the same thing, but you're just going to flip the switch and x becomes y becomes x. Final thing I want to point out, and I want to have you guys try this out on your own, just to kind of see how it works out. Given 3 points, I want you to find the equation of the parabola that contains the points. So this is actually kind of a trick question because if you think about what I'm asking for, there are technically 2 answers because you have one parabola that could possibly open up and down, whereas you could have another parabola that's going to open sideways, left and right. Now, again, back then, if I were solving, let's say if I was trying to solve for the one that's up and down. The one going up and down, we're going to look at the general equation. Y is equal to ax squared plus bx plus c. So our orientation would look something like this then. And just to kind of like, draw out what it looks like, your parabola is going to look maybe something like this then. Okay, so that's what it's going to approximately look like. In order to solve for that parabola, I'm going to go ahead and take those points and literally put it into that general equation then. So 0 is equal to a plus b plus c. And then for the second one, we're going to do the same thing. Then that means that 2 is equal to, ooh, not nice right there, 17 squared. So what is that 17 squared? I think it's like 349 if I remember correctly. A, and then plus 17b, and then plus c. And finally, we'll take that last point and we'll do exactly the same thing and plug that in. So that's equal to 3 is equal to 169a and then plus 13b plus c. And the way we go about it now is that because we have 3 equations, 3 unknown, we're going to go ahead and use the solve a system equation to get our answer. And then once you solve for a, b, and c, and then that's going to be your answer then. Now, unfortunately, this is not exactly a nice one. So we're going to go ahead and kind of, look at the other example then if it's okay with you guys. I'll leave this over here. But let's say for the sake of argument, now what I want to do is I want to go ahead and solve for the other parabola that is the other orientation. So rather than having it go up and down like this, let's go ahead and say we're going to look for the parabola that is going to be sideways. So if you can kind of excuse me, I'm going to go ahead and erase this right here. And the parabola that's opening sideways will look something like the following then. So here to maybe like say over here, and then maybe like say here to here. And in that case, what I want you to do is I want you to take that similar approach and maybe you can solve for this parabola yourself. So with the same point, right, if I want to solve for the blue, first I'm going to write the following. X is equal to ay squared plus by plus c. Same as before, we're going to go ahead and take those points and plug them in for x and y, and then we're going to go ahead and hopefully solve for the system equation. So what I'll do is I'll go ahead and set it up, and then afterwards I'll leave you the answer, so then that way you can have it for try. So in the first case, if I take that first point, now remember, x becomes y becomes x. So that means x is 1, so that means 1 is equal to 0a, so that's kind of nice. So 0a, and then plus 0b, and then plus c. And hey, would you look at that? We saw for c already, that's equal, c is equal to 1. Taking our second point to plug it in, then that is going to say now 17 is equal to 4a plus 2b and then plus c. And then finally for the last point, we'll go ahead and do that as well. 13 is equal to 9a plus 2b plus c. So like I said, I'm going to leave this to you guys to try to solve for this for yourself. If you do everything correctly, you're going to end up with the following equation. X is equal to negative 4y squared plus 12y and then plus 1. So, go ahead and try it out. See if you can get that. If you can, that's great. Leave a comment to say that you did it. If you didn't, well, practice makes perfect. All right, I'll talk to you guys next time. Have a good one. Bye.